Okay, here we go. Here's some basic derivatives. I'm going to run through the basic derivatives practice sheet, and I'm going to talk fast and furious and see if I can get through this fairly quickly. So in this case, I'm just using the power rule 4 times. Well, actually, that last one's a constant, but so that's going to be 12x cubed plus 3x squared minus 6x plus 0, so I don't bother writing it. Over here, this is just the exponent rule. So that's just the natural log of 5 times 5 to the x. Here's another power rule. That's going to be 15x squared plus 8x. Notice that I'm reassuring to label what I'm doing so you know. This is just got to use the trig rules, the appropriate trig rules, but also because it's separated by a plus sign, I can just take the derivative of them separately. So the derivative of sine is cosine, and the derivative of cosine is negative sine. Okay, this one, first thing I would do is rewrite it as x to the 5/3. So then when I take the derivative, it's just a good old power rule. So that'd be 5/3 x, and 5/3 minus 1 would be 2/3. And this one, I would divide the x squared in first. So that's going to give me 5x plus 4 minus 2x to the negative 1 plus 4x to the negative 2. So then when I take the derivative, it's all power rule. So that'd be 5, that'd be 0. Well, okay, that's not the power rule, that's constant rule, but plus 2x to the negative 2 minus 8x to the negative 3. Okay, and this is, I can just take the derivative of them separately and add them together. The derivative of ln x is 1 over x, and the derivative of e to the x is e to the x. Those are fun ones. Here I'm just grabbing the appropriate trig rule. The derivative of tangent is secant squared, and the derivative of secant is secant tangent. This is a good old power rule. Once again, multiply out front by 2/3, drop the power by 1, so that'd be negative 1/3. And this would be negative 4/3, and drop the power 1, and that'd be negative 2/3. Okay, the derivative of log base 5, that's going to be 1 over ln 5 times x. Here's another power rule. F prime of x is equal to 20x to the 4th plus 14x plus 1/2 x to the negative 1/2. Because remember that that's the same thing as x to the 1/2. Right? And here we go. Another trig one. That would be negative cosecant x cotangent x minus cosecant squared x. This is a hodgepodge of problems here. We got power rule, exponential rule, and sine. So that the first one is the power rule. This is the exponential rule. Don't let it get confused with the power rule. And then finally, we got cosine x. This I just divide the x in first, so I get x cubed minus x squared. So then the derivative would be 3x squared minus 2x. This, again, I divide the x to the 1/2 in first. And that'd be 4x to the 3/2 plus 3x to the 1/2. Then I'd take the derivative, and that would be 6x to the 1/2 and plus 3/2 x to the negative 1/2. And finally, this one I would also divide x to the 1/3 into that, and that would give me 1. And that would be x to the 1/3. And then finally, that would be x to the 2/3. And then I take the derivative of that, of course. And the derivative of 1 is 0. The derivative of that would be 1/3 x to the negative 2/3. And the derivative of that would be 2/3 x to the negative 1/3. And that's the first page. Ooh, we did that fast in 4.4 minutes, or 4 minutes and 40 seconds. Okay, so we'll keep the running going. So this is going to be f prime of x is equal to 6x. F prime of x is equal to 3x squared. F prime of x is equal to just 5, and f prime of x is equal to 1/2 x to the negative 1/2. Whoopsie-daisy, f prime of x here would be 8x plus 1. F prime of x, well, that's equal to x to the negative 2, right? So that would be negative 2x to the negative 3. And this is just 4x to the third. And finally, f prime of x, that's going to be 3/2 x to the 1/2. Just a power rule. Okay, so this one is just take the second derivative. So I'll take the first derivative first. That gives me, that gives me 6x squared plus 2. Then I take the second derivative. So in other words, I just take the derivative again. And that would be 12x. Okay. This one I'd probably just multiply that through. So that'd be 1/2 x to the 4th plus 7/2. And then the first derivative is going to be 2x cubed plus 0. The second derivative would be 6x squared. The first derivative here would be 5/2 x to the 3/2. And then the second derivative, of course, so that would be, what, 15/4 x to the 1/2. This one I'd rewrite that as, 1/5 x squared plus 1/5. And the first derivative would be 2/5 x. Second derivative would be 2/5. Let's keep going here. First I'd write this, what's the deal? First I'd write this as x plus x to the negative 1. So then f prime of x is 1 minus x to the negative 2. So then f double prime of x would be 2x to the negative 3. This one, we could use the product rule, but I think I'll just multiply this out first. 2x times, maybe I will use the product rule since it'll expose you to. So remember, the product rule says that you take the derivative of the first times the second plus the derivative of the second times the first. So I'm going to take the derivative of this first thing first. So f prime of x is going to be, the derivative of 3x squared plus 6 would just be 6x. And then I multiply that by the second thing. Then I add that to the first thing, 3x squared plus 6. And multiply that by the derivative of the second thing, which is just 2. So now I think I am going to multiply this out. So notice this is just the first derivative still. That would be 6. No, it wouldn't. It would be 12x squared plus 6x plus 6x squared plus 12. Now if I take the second derivative of that, I get 24x plus 6 plus 12x. Of course, I could add those two things together, and I get 36x plus 6. And the first derivative of this, come on, dudes. First derivative of this would be 24x to the 7th plus 2. And the second derivative would be, well, what's 7 times 24? That'd be 140 plus 168 x to the 6th. And the first derivative of this would be 1/2 times 4 is 2x to the negative 1/2 plus 3x squared. And the second derivative would be negative 1x to the negative 3/2 plus 6x. Do I have time? Oh, it's not even 10 minutes yet. Here we go. going to keep going. This has a warning here. Some of these may require advanced techniques. First one doesn't, though. It's just the power rule. That'd be 10x to the fourth minus 4x squared plus 7, and derivative 2 is 0. Okay, this one does require you to remember the chain rule, because notice this is a cosine of something. So y prime would be negative 2 sine of 3x times the derivative of 3x, which would be times 3. So I would rewrite that as negative 6 sine of 3x. Awesome. Okay, this you could multiply that out, but that's a bit of a tedious thing. So I think what I would do is just apply the chain rule here, because this is like u to the third. So the derivative of u to the third would be 3u to the second times the derivative of u. Well, the derivative of u in this case is just 2. So that would be 6 times 2x plus 3 squared. This, notice, is something times something, and x squared times e to the 1x. I'd probably write this as x squared times e to the x to the negative 1, just because that's cleaner. So we have two things multiplied together that have both contain a variable. So this is going to involve the product rule. So f prime of x, I'm going to take the derivative of the first thing, which is 2x, times the second thing, and then I'm going to add to that the first thing times the derivative of the second thing. Well, the derivative of this, the derivative of e to the, is e to the times the derivative of what's in the exponent. So the derivative of e to the negative x would be negative x to the negative 2. And we can simplify this, because this would be e to the negative 1, but that x to the negative 2 times x squared would cancel each other out, so I'd be left with just a negative e to the x to the negative 1. I think I would rewrite this as t minus 3 to the negative 2. Then I don't have to worry about the fraction. So then the derivative would be negative 2 times t minus 3 to the negative 3 times the derivative of t minus 3, which is just 1. So that's done. Here is another, well, this could be a product rule. However, I could rewrite this as the square root of x squared times the square root of 1 minus x squared. So then that's actually equal to the square root of x squared minus x to the fourth. So then, and I would rewrite that as x squared minus x to the fourth to the 1/2 power. Oh, there's the ugly x. So now I'm ready to take the derivative, right? So that's going to be 1/2 times x squared minus x to the fourth to the negative 1/2 power times the derivative of the inside, which would be 2x minus 4x cubed. And I can distribute that 1/2 through there, so that's actually going to be x minus 2x cubed over the square root of x squared minus x to the fourth. Why is it over? Because the negative exponent. Why is it square root of? Because that's 1/2 power. Okay, and here's another chain rule. So I multiply it. I take so I think of this first as 1/4 u squared. So the derivative of that would be 1/2 something to the first, and that something is sine of 2x. Then I'd multiply that by the, of course I don't need the first, multiply that by the derivative of sine 2x, which would be cosine 2x. Multiply that by the derivative of 2x, which would just be 2. So then that's going to be sine 2x times cosine 2x. And finally, the derivative of that would be y prime is equal to ln2 times 2 to the negative 3x times the derivative of negative 3x, which would be negative 3. So that would be, what, negative 3 ln2 times 2 to the negative 3x. But of course, that could be written as y prime is equal to ln of 1/8 times 2 to the negative 3x. All right, I think we made it. Wait, is there more? Oh, there's one more down here. Oh, there's all of these, yeah. Okay, we got 15 minutes left. I mean, 15 minutes so far. I guess I'll do it. Okay, so here's this hardcore product rule. So I'm taking the derivative first, which is going to be 2 times x cubed minus 4 times the derivative of x cubed minus 4, which would be 3x squared. And all that's multiplied by the second, 2x plus 5 cubed, plus, then we write the first, x cubed minus 4 squared, times the derivative of the second, which would be 3 times 2x plus 5 squared, times the derivative of 2x plus 5, which would be 2. So if we clean this up a little bit, we get 6x squared times x cubed minus 4 times 2x plus 5 cubed. And since this x cubed minus 4 doesn't have any powers on it, I actually could multiply that 6x cubed through. So that would be 6x squared times x cubed. That would be 6x to the 5th minus 6 times 4 is 24x squared. There we go. And then if I simplify this one, this is just going to be 6 out front. And then since these have powers attached to them, I'm not going to mess with them. I'm not going to multiply them out or anything like that. Okay? Fine. All right. Here's another one. F prime of x. The derivative of the first would be 1/2 times 6x plus 7 to the negative 1/2 times 6 times 8x minus 1 to the 3/2. So this is this whole section here is the derivative of that. And then this, of course, is just that, as is. Plus, then I'm going to just write 6x plus 7 to the 1/2. And we'll color that in yellow because that's coming from the yellow spot up there. And then the derivative of that second thing would be 3/2 times 8x minus 1 to the 1/2 power times the derivative of 8x minus 1, which would be 8. So then that, of course, is the derivative of the green thing. Now we need to clean all that up. So we're going to get a 3 here times 6x plus 7 to the negative 1/2 times 8x minus 1 to the 3/2. And then we're going to get 4, that'd be plus 12, because the 8 and the 3/2 there, times 6x plus 7 to the 1/2 times 8x minus 1 to the 1/2. Okay, I think we got one more here. Yep, one more. So this is going to be a product rule again. And take the derivative first. That would be 2 times sine of 2x times the derivative of sine x, or sine of 2x, which would be negative, or no, it'd be cosine of 2x times the derivative of 2x, which would be 2, times cosine of 3 or cosine cubed 2x. And then we're going to add to that sine squared of 2x times the derivative of this cosine cube. So that would be 3 times cosine squared 2x times negative sine 2x. Oops, I'm running out of room here. Shoot. Well, here, I'll come down here and rewrite this. So that would be 2, no, that would be 4, because of the 2's, and sine 2x, and that cosine can multiply by that, and it'll give me a cosine to the 4th 2x plus. Now I have more room here. So this is going to be sine of 2 times 2x, 2 of 2x, sine squared of 2, sine squared of 2x times 3 cosine squared of 2x times negative sine of 2x times 2. So just to be clear on this, I'll bring in my highlighter. So we'll call that yellow, and we'll call that green. So the yellow guy ended up being right there. Then all the rest of this is the derivative of the green guy. Okay? Same way up here, this is just the green guy. And that's the derivative of the yellow guy. Okay. Now let's clean everything up. This one's already clean. 4 times sine of 2x times cosine of to the 4th power of 2x. And then here, I have a 6. So they have 3 times 3 is 6, and then we have a sine of 2x there and there. And that negative, of course, is just going to go out front, so I'll put that there. And so how many factors of sine of 2x do we have? It looks like we have 2 there and 1 there, so that'd be 3. And then finally we have a cosine squared 2x. So that's pretty cool. Not bad at all. All right, that concludes this. So keep practicing these and practice the practice quizzes online, and make sure you should be working on the homework, homework 4. And you just got to get better and better at these derivatives.